Researchers at the Scripps Institution of Oceanography say by the end of the century, California will see 10 fewer rainy days a year, which could have a major impact on the environment. Scripps research meteorologist Alexander Gershinoff, welcome to Evening Edition.
Thanks, Peggy. Glad to be here.
Now, Alexander, we've already experienced one of the driest years here on record in San Diego County. Put this 10-day reduction of rain into context for us.
Well, we already in a region that's so-called Mediterranean climate regime, which means that most of our rainfall comes in the wintertime and the summers are dry. So we have a narrow window in which to generate our annual rainfall. And that means that the difference between a couple of storms, more or fewer, can actually make the difference between a wet and a dry year here. We have very strong variability from year to year, volatile water supply. And if in the future we have even fewer rainy days, for one thing, that will mean that even more of our annual water supply will depend on one or two storms, and the variability from year to year of annual rainfall is going to increase even more.
So this is actually going to be a bigger gap and a smaller window of what we could get for rain. Does this mean that San Diego, in our region here, that we'll be in like a perpetual state of drought, or will those rainy days that we do get be different somehow?
Well, what we see from these 28 global climate models that we analyze that now provide daily data is that almost all of them agree that the frequency of rainfall will decrease in our region as well as in all other Mediterranean climate regions around the world. But at the same time, the intensity of the most intense precipitation will increase. So when you add that all up and you average over a year or decades, as what's typically done, you don't see much change because these two changes, less frequency but more intensity, cancel each other out.
So in other words, I hate to use this, but when it rains, it's going to pour, and then there's going to be these big gaps in between. Let's take a look at a map, a computer map used in your research. And as you said, this computer map that we're looking at is actually a bunch of models here combined, correct?
It's 28 models, as a matter of fact. And so these reddish-brownish regions show where models agree that the frequency of rainfall will decrease in the second half of the century. I mean, it's a gradual decrease, but this shows where the models project the frequency of rainfall to decrease, and the blue regions is where the frequency of rainfall is projected to increase.
Which we see is at the North and South Poles and the equator.
Yes, the meteorological equator where the trade winds converge the moisture from both hemispheres. In a warmer atmosphere, there's more moisture, and it's going to rain more frequently and harder there. Whereas for us,
let me ask, because since we just saw that, what kind of impact could that, those red that we're seeing, these very dry periods, what kind of impact does this less amount of precipitation have on our environment?
Well, for one thing, if you have longer periods, longer dry periods, and the rainfall coming in less frequent but more intense spurts, that means that there will be years when the vegetation will remain dry into the middle of winter, kind of like what happened this year, actually, The middle of winter here is the Santa Ana season. So our fire regime, for example, might actually shift and extend further into the winter when the Santa Anas are more frequent. So that's just one example of what may happen.
Right. Do we know what's causing this shift in the pattern?
Yes, this shift makes perfect sense meteorologically because global warming is not uniform around the globe. The polar regions are warming more than the tropics, and it's that temperature difference between the tropics and the poles that actually drives the mid-latitude circulation of the atmosphere and determines the storm tracks that bring the storms to us. Most of our storms, most of our precipitation comes from so-called mid-latitude cyclones. They look like comma shapes on satellite clouds. They're centered far north, and we get our precipitation most typically from the tail ends of these storms. So
if that's shifting, it's going to shift.
They shift further north in response to this decreased equator to pole temperature gradient, those tail ends will pass north of us, and we get less precipitation. So that makes perfect sense. That's what we actually expect.
I know there's a lot more to this, and I want to let folks know because we're out of time. They can read a lot more about this on our website, kpbs.org. Research meteorologist Alexander Gershunov, thank you so much.
Thank you, Peggy.